So I'm now going to share my screen, if I can do that. Can someone just confirm for me that they can see that screen and hear me?
Yep.
What I kind of decided with the title of my talk was to address something about the state of British rivers, but at the same time talk about a problem that for a very long time has been hidden beneath the water surface, except for those of us who are freshwater biologists or anglers or wild swimmers or people who get involved in contact sports with water. And that is the problem of river pollution and, in fact, its biological effects. What's really interesting, actually, around the very heated debate and the evidence that's arising about the state of rivers, actually, much of this is now coming into the open. So I think this is less out of sight and out of mind than actually it used to be. What I'm going to try and go through in this talk, I'm going to be drawing quite heavily on my own research, the research of my group in Cardiff. I'm going to just give you a little bit about my background, how I came into freshwater ecology. I will illustrate and remind people that the loss of freshwater biodiversity is a global crisis. I will talk about two things which are probably success stories, but illustrate the magnitude of the challenge in fixing freshwater pollution problems. And then just skate over a little bit some of the murkier side of freshwater pollution around urban issues, legacy chemicals, plastics, pharmaceuticals, agricultural pollution. Now, I'm hoping that, in fact, we will come to a discussion about the solutions, and anyone who will have listened recently to the briefing room, this particular episode on Britain's dirty rivers, will already have a bit of a notion of the problems we face and what some of the solutions could look like. This programme revealed to the world, for example, people in Britain, that only about 15% of England's rivers are in good ecological status according to European criteria. In Wales, that number is about 40%. In Scotland, it's about 55%. But in all of those instances, clearly, well over half of our rivers have some kinds of problems that affect them reaching what we call good ecological status. And it's a mix of problems around the amount of water we remove, concentrations of nutrients, toxic chemicals, rural pollution, urban pollution, mine water wastes. And I will skirt on some of these issues as we actually go through this presentation. Just to talk a little bit my own background, you may guess from my accent that I am from the North Country, and I grew up, I was born in 1958 in Burnley, which not many decades before had been the biggest producer of cotton cloth anywhere on earth. And the rivers that flowed through Burnley were affected by waste from industry, they were affected by mining, they were affected by poorly performing sewage works. And so I grew up firsthand with some kind of insight and appreciation about what really polluted rivers, grossly polluted rivers in urban areas actually look like. I then came in 1980 to do a master's degree in applied hydrobiology in Cardiff University, what was then UIST, where we had also a range of problems with mine water waste and other issues. This man in the bottom right here, Ron Edwards, was establishing what was at that time one of the biggest groups in Britain working on freshwater systems. And it was no accident that this was occurring in Wales, because Welsh rivers at that time were some of the most polluted on earth. I went on from there to do a PhD, essentially charged with making some predictions about what might happen with the large-scale reservoir enlargement in the upper part of the Wye Valley, a water transfer scheme through which water would be transferred out of this Eland system into the Severn, into the Thames and sent to London. And so I started to look at what the water quality implications that would have for organisms like insects that lived in the river and are such a crucial part of the river ecology and economy. Around about the same time, much to the aggravation of my PhD supervisor, I discovered these fantastic river birds, which are entirely dependent on production from rivers. This is the dipper, one of 5 species of dippers in the world, the only songbird that can swim and dive to collect insects from the riverbed. And I started to look at the extent to which these wonderful birds were not only dependent on insects living in the riverbed, but also they reveal to us how changes amongst the insect prey that they depended on were at risk of pollution impacts. So my research models have always been the organisms that make up food webs in rivers, that contribute to ecosystem processes like production and decomposition, and in the end are responsible for many of the fantastic, delightful things that we are exposed to when we look at a healthy, clean river environment. Also around about the same time in the 1980s, I discovered paradigms that were coming out of really major seminal ecological thinkers in the United States and Europe, who were telling us that the characteristic of river environments, be they in the Himalayan mountains or the Athabasca region of Canada, or the Hawaiian Islands or upland Wales or Nepal, people were pointing out that the characteristics of rivers depended very closely on the characteristics of the landscapes, the catchments from which they drained. And it kind of hit me that if we were modifying river catchments to the extent that we are, then that same principle of catchment influences would somehow be conveyed downstream through anthropogenic modification to rivers, to the organisms and ecosystems that were indicators of those changes, but also reflected in their diversity status, what those pressures on river catchments might be. Now, it's germane, therefore, that we should consider at this point the extent to which the modification of the world's rivers has given us some very clear evidence that the loss of biological diversity in rivers is amongst the fastest of any ecosystem anywhere on Earth. Rivers are hotspots for global biodiversity because of the number of species that live there, but they're also hotspots for human use and exploitation, for water supply, for waste disposal, for navigation, for a whole range of things. And this thing called the Living Planet Index for freshwater ecosystems illustrates something like an 80% plus collapse of monitored freshwater populations around the world since 1970. That is faster than in marine systems, faster than in terrestrial systems. And there are some caveats around these data, but they're nevertheless indicative of the fact that when we look at the state of rivers, we are looking at a global problem to which British users of water and abusers of water also contribute. Now, also on this day, when the COP15 on biological diversity is in full swing in China, thoughts around bending this curve, reducing the loss of biological diversity, has come very much to the fore. And I was part of a team of people who put together this action plan for arresting the decline in biological diversity. And you'll see there at number 2, reducing pollution is one of the bigger challenges around bending this curve, trying to restore river environments around the world. Now, I did say I would start with 2 success stories, and success stories is in inverted commas. And I want to take you to where my career in freshwater biology started in the early 1980s, looking at problems of acid rain, which in Wales, with our base pore rocks and soils, we were very much affected by. And in fact, the problems that we faced not only changed the characteristics of things like the insect communities, the mollusk communities in rivers, but the effects pervaded food webs, because river birds like the dipper were dependent on exactly the same insect types and mollusk types that were being knocked out by acid rain. And those effects pervaded right the way through the whole life cycle of these river birds, affecting eggshell thickness and the growth of chicks and the survival of chicks. So here was an indication that food webs were impacted by a pollution problem that equally illustrated to us how the diversity of insect types was also being affected and depleted. So what we look at in this figure, some very old data from the 80s illustrating how the richness of different kinds of insects, mayflies and caddis and all invertebrates in general, declined as concentrations of metals like aluminium increased in the water where pH dropped, in other words, where rivers became more acid. And now what we've been looking at, in fact, since this time, is the extent to which recovery has occurred amongst these same organisms and in the same chemical effects that pollutants very clearly were having. We established a project in the early 1980s called the Llynbrioni Stream Observatory. And this project, this series of streams around Llynbrioni Reservoir in central Wales, reflecting different kinds of land uses, either conifer or moorland or deciduous woodland, has examined since the 1980s to what extent there has been recovery from the acidification problem. What our data showed us was that not only was atmospheric deposition of acid pollutants a problem, but that deposition was exacerbated by certain kinds of land uses. So commercial conifers increased the amount of sulfur and nitrogen deposition falling onto the soils. That was driving acidity. And the kind of management suggestions that came from this was around how we distributed new conifer plantings, as well as how we addressed the problem of large scale emissions of sulfur and nitrogen from industry and power stations. And what we've seen since the 1980s at our sites in Llynbrioni and indeed across Wales is how large-scale controls of the emissions of pollutants from power stations across Europe, as well as some industrial decline, has taken into these circumstances where year on year the pH of rivers in upland Wales has increased. So in other words, by tackling at a European and indeed international scale the source of the pollution problem, we have been able to see evidence that recovery has been occurring. It's not yet complete, but it has been occurring in streams in upland Wales, and this is repeated also in Scotland and in Northern England and in various other places around the world. It tells us something about the timescales required for recovery, but it tells us that when we take appropriate action, we can have some kind of success. Now, not everything is as yet appropriate for biological recovery. And in fact, when we look at long-term trends in the numbers of insects in our streams in upland Wales, at Llynbrioni and elsewhere, in fact, what we see isn't biological recovery, but a continued year-on-year decline. And we're pretty confident that this is an effect of climate change. So we see also at Llynbrioni, as the temperatures have increased, so have the abundances of insects and invertebrates declined. And in fact, the abundances of organisms, our streams, these things that are important for birds and bats and various other things that live along the river, have gone down by about 20% for every 1 degree centigrade rise in temperature. We think we understand why this is occurring. We have some notions around how we can at least reduce some of the effects. But again, it illustrates the complexities of dealing with pollution problems, because they very often occur in multiple in the places where we're trying to have some kind of management action to restore problems, to recover streams that are damaged. Now, the second major success story that I want to say something about is that may surprise some people, but it's about the recovery of urban rivers from the past effects of gross pollution. This is an image taken near to Merthyr Tydfil in the early 1900s, and it illustrates something of the state that Wales was in when it was a wholly industrial economy linked to coal mining, to coking, to gasification, to all kinds of other effects that had downstream impacts on the major rivers that drain the South Wales coalfield. Now, there's another interesting problem in South Wales, which is that many of the towns actually can't really fit easily on the hillside, so they're concentrated along the valley bottoms. Any sewage that is produced in settlements like this can only be collected by sending it in sewer pipes that very often followed river valleys. And back in the 1960s and 70s, we actually faced not only an industrial problem in urban South Wales, but a problem of leaking sewer pipes, leaking trunk sewers, and poorly performing wastewater treatment works. This image actually is from Yorkshire, it's from London Foot, but it's the only one that I could find of a sewage pipe crossing a river. In the 1960s and 70s, 70% of the rivers draining the South Wales coalfield, because of these combined problems, were classified as grossly polluted. They were dire. The diversity of insects was extremely low. There were all kinds of problems with smells and odors and all kinds of other issues. And then from essentially in the mid-1980s and then the 1990s onwards, we have witnessed a remarkable recovery in clean water organisms, and that is repeated in lots of different urban areas across the United Kingdom. So we can now see within about probably 2 miles of my house here in Cardiff, clean water organisms like the dipper. We can see clean water organisms like otters. Here's the famous angler Will Millard holding a salmon that he caught in the River Taff. Salmon returned to the Taff as they returned to many other urban rivers across Britain in the 1980s and 90s. And we also have clean water insects that are quite widespread in these areas, like mayflies in the bottom right of my figure here. Now, we've documented this, this change using data collected by our regulatory agencies. So back in 2012, we illustrated using about 20,000 locations across England and Wales, 200,000 samples, 20 years of data, these progressive increases in organisms sensitive to pollution that are illustrated in these two figures on the left-hand side. This is a recovery that we should not overlook, and it is the effect of not a bit of it industrial decline, but also regulatory instruments such as the Urban Wastewater Treatment Directive. We are currently updating this analysis, and we, up to 2019, have no reason to believe that the trajectory of recovery in England and Welsh urban rivers has changed. That recovery has continued. Now, however, we are, again, I'm going to put a question mark over the extent to which this is genuine recovery, because as we know from the Rivers Trust and others, there are still many locations across England and Wales where wastewater treatment works aren't performing as they should be. We have issues around combined sewer overflows. We have issues with those same CSOs not performing as they should. And linked to those CSO problems, wastewater problems, urban problems, we can still see in these rivers that have been recovering from gross pollution the ongoing effects of other kinds of emerging and legacy pollutant problems. So these data are data on two complex sets of chemicals. They were collected by various colleagues of mine as part of my team. Flame retardant chemicals such as PBDEs, PCBs, these industrial chemicals that have been banned from production for several decades. accumulating in river food webs in the South Wales valleys to reach concentrations in the eggs of river birds down here in the valleys that are among the highest ever recorded in songbirds anywhere on Earth. And they are at concentrations which are, we think, large enough to create detectable effects in the developments of chicks. And we have documented and published some of this evidence. Equally, we are aware through a whole series of publications going back now over at least 10 years that our rivers are receiving things like pharmaceutical products from people and from animals. Some of these data are being produced from the University of York, from the University of Leeds. This paper at the bottom was on the TAF system, produced from the University of South Wales. And a particularly interesting component of this, as well as illustrating that anti-inflammatories, diabetes treatments, whatever condition you might take pharmaceutical products for, you metabolize part of that pharmaceutical, but some of it inevitably finds its way through wastewater treatment works and finds its way into the river environment. And one particular interesting case that we've started to hear about recently is around veterinary treatments, in particular for domestic pets, where compounds such as imidacloprid, which is a neonicotinoid insecticide, fipronil, another insecticidal compound, is given to dogs and cats systemically, either in a pour-on or in a drug that they take every 2 or 3 months. And the evidence we have shows that pretty much in most English rivers where these compounds have been sold, they are reaching concentrations that could be high enough to have detrimental effects on insect life. They are designed to be biologically active. They are designed to be insecticidal, and the concentrations in rivers are sufficient to have insecticidal effects. This is my own dog, Leo, and we stopped giving him any kind of prophylactic flea treatment as soon as we heard this evidence. And we're now, of course, looking out for symptoms, and we'll treat issues symptomatically rather than prophylactically, so that he's not contributing to these problems. I should say, we've looked through MSc students, we've looked for the same kind of chemical signals from pharmaceuticals and from veterinary flea treatments in the TAF system recently. And I can tell you that concentrations increase as you progress down the TAF, but also more interestingly, this tiny little stream here called Roth Brook has no wastewater treatment plant on it. It has no combined sewer overflows on it, and yet we find the same range of pharmaceuticals that we find in the main river, and we think this is associated with sewer misconnections that are leading to wastewater finding its way into this small brook. And we can measure chemicals such as caffeine that are traces of wastewater material, a metabolite, again, a drug that's used by people intentionally in this particular case, being used potentially as a tracer for a whole range of other pharmaceutical agents. So I want to come on now and just talk a little bit about plastics, which, of course, many of us, when we hear about, we think of problems associated with large pieces of plastic, very often interfering with the lives of animals, particularly marine animals. Well, now about probably 4 or 5 years ago, we decided also to look at whether there was a problem in urban river environments, in Wales in particular. And what we discovered from reading the literature was that there is something like 8 to 12 million tons of plastic going into the world's oceans every year. A large component of that, at least 4 million tons, is coming through rivers. And we think about 1 to 2.5 million tons of that is arriving into the world's oceans in microplastic form. So our question was, what might that be doing in the river environment, and how much of it might actually be present. Now, we had another few pieces of data that started to arise around the same time, just after we started our work in 2016. These were data measured by colleagues from Manchester University, who looked at the amount of microplastic fragments in sediments in different parts of the world, beach sediments and lake sediments. And what they discovered was that the highest concentrations they measured anywhere, about 500,000 fragments of plastic for every square metre of riverbed, was in the Ormerod system in Manchester. And this same team has gone on to illustrate how this material is probably arising in lots of pulsed discharges, in this case from CSOs and from wastewater treatment works. But what about its interactions with organisms? Well, this again was work carried out by some of my students, Fred Windsor and Rosie Tilley. We asked the question whether wastewater treatment works were giving rise to microplastics. Were they detectable in organisms? Were they finding their way through food webs into birds like the dipper? And what our data showed us, we looked at 5 different locations upstream and downstream of wastewater treatment plants. We looked in different kinds of insects, filter feeders, grazers, and what we found absolutely staggered us, that we could find plastics pretty much everywhere we looked, upstream and downstream of wastewater treatment works, which raises a question about other sources than sewage. We find microplastics in all of the insect species we studied, and something like 1 in 2 of all the insects we looked at, and these were samples of hundreds to thousands of individuals, contained plastics, mostly fibers, with a few other kinds of fragments. And I have to tell you also that we have entirely corroborated these data in 2021 through an MSc student who has recently been looking upstream and downstream of some other wastewater treatment works. So the question, the next kind of stage of this research was to look at whether birds like dippers were also ingesting microplastic because their prey was contaminated. And again, the evidence was clear that we could find microplastics in the droppings or in the regurgitates of dippers. At 14 of the 15 sites we looked at, it was mostly fibers again. And we were able to calculate, based on the amount of plastic in prey and the amount of plastic that was going into the dippers and coming out of them, that chicks are probably being fed about 5,000 to 8,000 microplastic fragments, even before they fledge as adult birds. Adults are ingesting probably about 200 microplastic fragments on a daily basis. Now, at this point, we don't know whether there are any effects from this. But clearly it tells us something about how this pervasive, very long-lasting pollutant is finding its way through river ecosystems. Now, if there is a silver lining in this story, when we measured the likely inputs of plastic in the prey that birds eat and the amount that was coming out, there was a rough balance between these two things. So this plastic at least appears to be transitory in the birds, but nevertheless, at any one time, a dipper probably has several hundred pieces of microplastic somewhere within its alimentary canal. The evidence we produced did have some kind of policy impact. The Welsh Government, our Senedd Climate Change Committee, carried out a particular review into the potential effects of microplastics in Welsh waterways, but it is something, it's an issue that we need to know far more about. We are continuing with this work. We're looking at whether other kinds of plastics, such as tire dust, is an overlooked contributor to the fluxes, the movements of plastic through our Welsh river systems. And also we've taken a slightly unusual line, looking at food web transfer of plastics, not only within river food webs, but actually to the organisms in the surrounding locations. So some evidence published in Reading University a few years ago on laboratory evidence illustrated that if mosquito larvae were fed plastic material, they would carry that material into the atmosphere when they emerged. And we asked the question whether birds like swallows that were feeding on aerial insects, or bats that were feeding on aerial insects, might also be contaminated. And in fact, I can today reveal for the first time that microplastics are present in real world system in insects that emerge from rivers and lakes, and they are ingested by birds like swallows and mammals like bats. So yet another potential route for microplastic transfer. Now, at this stage, I haven't said it very much about rural rivers, and very clearly not all our problems in the river environment are in urban locations. And there are some really interesting indicators from, again, my favorite riverbird species, the dipper, which we know has been increasing in population in urban areas, but across the United Kingdom as a whole, its populations have been thinning out from the 1970s onwards. And because the increases in population are in urban areas, then it kind of follows that much of this reduction in population must be along Britain's rural river environment. And you know, there are just as many complexities and challenges around understanding pressures from agriculture on rural rivers as they are understanding the problems of urban pollution on urban rivers. But we can illustrate, for example, in locations which have been progressively converted to more and more intensive agriculture, that certain kinds of invertebrates systematically drop out of the food web. So filter feeding organisms that might be affected by sediments, surface grazing organisms that depend on algae that might be affected by eutrophication issues, just as two particular examples. Now, we've heard a huge amount about rivers like the Wye and the Usk and other rivers that have some of the highest possible protection of any river systems in Europe as special areas of conservation. There are strong suspicions around the extent to which these rivers are changing ecologically. There are suspicions around the sources, which might be intensive agriculture, they might be diffuse agriculture, they might be small-scale wastewater treatment works and cesspits, they might also be poorly performing wastewater treatment works. And there is an inventory of phosphate sources in particular that is currently being carried out to tie down exactly what the sources of phosphorus are in this river system and what we can do about it. At the moment, we can say that large parts of the Wye and the Usk and other rivers in Wales are exceeding standards for phosphorus that are laid out from the Joint Nature Conservation Committee as being likely to cause biological damage. So I'm going to try and wind up at this stage by illustrating that very clearly rivers are at risk from a range of pollution problems. The organisms that are affected essentially reflect everything from microbes up to apex predators. They're sensitive in various ways. They're acting as indicators that tell us about the state and trend of rivers. They're important in ecosystem processes, but I think it is important to point out that not all trends are negative, and where we have had positive effect, some of the options are revealed to us about what we can do to ease some of the problems. So regulation, climate change adaptation, appropriate land management, investment in infrastructure, potentially nature-based solutions, markets for ecosystem services, things that we can potentially come on and talk about. The risks are complex. They're very often arising in multiple. They're still evolving and emerging. We don't understand all of them. But just again, to remind everyone listening that this is not just a problem of the United Kingdom. We are contributing to global pressures on biodiversity in freshwater ecosystems that are among the fastest of any ecosystem anywhere on Earth. So at that point, Tony, I am going to stop sharing and invite any questions or comments if people have any.
I can see Will would like to ask a question. Can you unmute yourself, Will, if you're not muted?
I've done now, yeah. It was interesting watching your presentation. I've seen both ends of that. I was probably one of the first anglers to actually catch a fish out of the River Don in the middle of Sheffield, where I was doing some environmental work there and looking at invertebrates in the River Don, and happened to see some little dimples of fish feeding. Went down with the rod the next week and I got 2 little minnows and a little perch out the River Don, and the guy who was in charge of the project nearly fell through the floor when I showed him these fish. And since then, the River Don has vastly improved to the extent that they now have put salmon runs in River Don, so that salmon can get around areas in Doncaster that were impossible for them to get past and get up towards Sheffield so they can breed. And the same has happened on the River Aire as well, where again, it was an open sewer when I was a kid, same as the River Don. If you fell in the River Don when I was a kid, you died of poisoning, you didn't drown. But on the other hand, places where I used to go, like the River Witham and the River Ancombe in North Lincolnshire, and I suspect that the same is happening on the River Cam and the ooze from my brief visit down there the other year. And that is that you've got a very lowland river that when I was a kid used to have a highly coloured water. It used to have a sort of browny green content in the water that basically used to give fish cover. Now are crystal clear. Absolutely crystal clear. All of that, I don't think it was all sediment. I think that there was algae, floating algae that were in there, have gone. So it is crystal clear. They get masses of blanket weed in them now, and the fish have all but disappeared, or a lot of them have disappeared. And it's that I wonder very often if it's that effect of phosphates, nitrates coming in off farmland that have destroyed those sorts of rivers. And what on earth could we do about that, really?
So that I mean, your observations chime with the character of many rural locations where there are multiple sources of nutrients, be they phosphorus from phosphorus applications. Dairy, of course, is very, very famous for potential impacts with slurry and silage spills and various other things. The solutions are extremely challenging quite often in farmland, and I think they are about managing catchments in far more sensitive ways, very clearly using appropriate regulatory tools where people are essentially doing things on purpose that they shouldn't be doing, but on the other extreme, rewarding better practice to ensure that, you know, through advice and appropriate incentives, agri-environment schemes, that silage is appropriately managed, slurry is appropriately managed, that there are appropriate levels of phosphorus contributions onto landscapes that match essentially the productive requirements of any crops that are being produced, shifts in cropping patterns away from arable into grass cover crops. But in general, the answer has got to be around better catchment management. And it's also one of the areas where opportunities are increasingly arising that could give multiple benefits. So riparian woodlands to reduce climate change impacts, to increase denitrification, to provide habitat, to actually somehow absorb carbon. You know, so there's I think appropriate management, incentivized in agricultural locations has got to be the solution to those problems.
It's not just nutrients though. I think also the other thing that goes in is the pesticides and herbicides that go in there. That tends to attack the bottom end of the food chain, the single-celled algae and things like that. It affects them far more than the larger sort of pondweeds and stuff like Potamogeton and some of the silkweeds and stuff that are in the river systems, especially these lowland rivers like the Cam. And so they come to dominate rather than being shaded out by those diatoms and the single-celled algae. And it's the big problem is that we have to, as well as look at that management, look at how we can increase the bottom end of the food web to actually improve all of our rivers, I think.
We've got, do you want to say anything further, Steve? Because we've got another.
No, I think it kind of makes the point that we're dealing with complex, multiple problems to which the solutions are not always straightforward. But the solutions that are at our disposal can operate in ways that aid multiple stresses. What I'm finding really interesting in now are some of the markets for ecosystem services schemes that are being wheeled out. I mean, started with Wessex Water's kind of Entrade scheme, where farmers bid for the opportunity for funding to do things that reduce the pressures on surface waters and potentially water treatment downstream. And I think this is really interesting, you know, so raising the standards of actions on farmland in such a way as people could market their produce if it has been produced in an environmentally sensitive way that is validated, then receive a premium payment or a subsidy for that service, which actually allows them to farm in more appropriate, high nature, low carbon ways. But these are multiple stressor problems that we've got to actually address in appropriate synthetic catchment wide with catchment wide solutions.
Right. I notice, and I'll say your name wrongly again, Ofi, but you have a couple of questions. Do you want to ask them yourselves?
Yeah, sure. So one of them related to cost-benefit ratios around treating water, primarily for the sewage treatment companies or the water providers, where we have a situation where it is more cost-effective to release untreated sewage rather than treat the sewage. People are making financial decisions, which is, I mean, that's their remit in industry. But do you think there is a genuine political appetite to change this? Or will it always be, you know, what is the most cost-effective thing to do? And if the most cost-effective thing to do is to not treat water for better water quality, then we're in this never-ending cycle.
I'm not sure if I'm familiar with the economic arguments and the decisions that businesses take about whether it's economically more viable to avoid fines and to release sewage. I think that's a question you should take to the water companies. But water companies every 5 years go through what's called an asset management program. The 5 years that we are beginning now between 2020 and 2021 going up to 2025 will see about £50 billion of investment by water companies into addressing a whole range of issues. Some of it is around pipe work, some of it is around ensuring security of supply, but a substantial part of that funding is, and quite rightly should be, earmarked for reducing pollution problems. So all the companies have a pollution incident reduction plan. Very clearly, the more that performance issues around poorly performing CSOs are kind of brought into the open, then the bigger the pressure there will be for them to address those issues. In Wales, where I work, the estimated cost of addressing CSOs is something like 8 to 12 billion pounds. That equates to about £3,500 per person in Wales. So clearly this is very substantial expense if we are to address all the problems. Almost certainly we've got to prioritise. But you know, another part of this is the extent to which the regulators actually are trying to deliver investments in the water industry in ways that keep our bills affordable. So at the same time as there is this intention to spend, you know, tens of billions on cleaning up water treatment, off what the water company regulator is intending to reduce bills by something like 50 to 100 pounds per annum. And it's also cognizant of the fact that there are people who struggle to pay their water bills. So the economics of all of this are extremely challenging, very difficult. In my view, we've got to see the benefits of investment, not in the short term, but in the longer term, and essentially make the case for the importance of the investment decisions that are made.
Okay, and if you don't mind, I have one further question, where you talked about the decline in invertebrate populations in response to kind of catastrophic pollution events in the past, like Sandos in the River Rhine in the 80s. 10 years on, there were restocking programs for fish. Do you think there could be mass production of insects under laboratory conditions, and then the release of insects back into the river systems to try and support the higher predators?
That's a really two bits to that are really interesting. One is that actually angling communities, particularly in areas where there are, just to remind everyone that organisms like fish are not only important to angling, but they're also important to nature conservation. So Atlantic salmon, for example, is on the Habitats Directive, and there are potential negative consequences actually illustrated if inappropriate stocking takes place. So we're altering the genetic makeup quite often of strains of salmon that are adapted to local conditions. So stocking is less likely to be considered as an answer to fisheries problems now by comparison with, say, 40 or 50 years ago. All restocking with any organism is governed by guidelines which are laid down by the International Union for the Conservation of Nature, the IUCN, and there are several criteria. One is that there should be no damage on source populations, but also that the places where reintroductions occur have been managed to the point that the pressures that led to the elimination of the species in the first place have been addressed and managed. So I think, you know, that should figure in any of our decisions about restocking with any organism. My guess from the invertebrate perspective is that invertebrate dispersal is effective enough. The numbers of organisms that would have to be involved to really affect production are so astronomically large that artificial programs would never do the job to the same extent that nature would do the job. So I think we've got to do our best to solve problems of rivers where they arise and then wait for natural processes to take their place. And that's exactly what's illustrated in the recovery of urban rivers in Britain from gross pollution in the past.
Okay, thank you very much.
Thanks. I wonder if you were being quite kind to the water companies in the answer, not the last answer, but the previous one. I mean, some of us were down in Whitstable on Saturday where 800 people, I mean, it was an amazing gathering of people who were really in a state of shock at the amount of sewage going into the sea from southern water. And it was that something like at least half of the days, the summer days, nobody could swim in the water because there were notices put up saying it was too dangerous. Mm. And that southern water were fined 98 million, I think, in the courts, but their profits are several billion. And so 98 million, and they've been fined before. So it's not like they learned a lesson and therefore didn't do it again. I mean, and this is fining for illegal dumping of sewage in the sea.
And there were issues also in that case, weren't there, about almost purposeful miscalculation of data, as I remember. There were,
yes, you're right.
There were. I mean, I don't know the case in that much detail, but I think one of the ways we're thinking about this in Wales is around the way that action is prioritised. So I think we have about 3,000 combined sewer overflows in Wales that could still be problematic. The cost of solving problems in all of them is really extremely large. And let's not forget, this is a Victorian problem we're trying to solve through investment now. And the notion is around prioritising either which wastewater treatment works or which CSOs are the worst offenders, either through the number of discharges that they release under inappropriate flow, but also I feel we should be looking at exactly what is coming out of CSOs. So, microplastics, proper assessment of pharmaceutical products, antimicrobial resistance could be an enormous cost to the health of future generations unless we properly got on top of it. So I feel an appropriate prioritization program with enforcement when it is necessary, absolutely clearly, but investment to actually solve problems like the ones you've just described.
Yeah, that sounds good. I mean, there was a chap on your program who has a research project, and he only studies illegal release of sewage into rivers. That was his. So, and this is massive. I mean, there's a massive illegal release, of course. Yeah. Claire,
on the chat is questioning whether CSO means the Chicago Symphony Orchestra. If only it was so harmonious and beautiful, but combined sewer overflow. So this is it's a Victorian concept in Britain where we mix foul sewage with surface drainage, and the concept of CSOs is that that pooled water would overwhelm wastewater treatment works simply by flow volume if it hit the wastewater treatment works at the same instant. So the CSOs, essentially the combined sewer overflows, act as release valves to release that water with raw sewage into rivers under conditions where it would normally hopefully be diluted. But problems now arise where CSOs discharge even at low flow. And of course, we are, I think, increasingly thinking that the design of combined sewer overflows, it is a bit of a Victorian concept we should be trying to do something about. But what do? You can't just shut down a wastewater treatment works if you are mixing heavy flows from those two sources. We don't really want to have sewage backing up in our toilets, so we do want to get rid of this water. So the ideas that are emerging are around things like sustainable urban drainage schemes, where rainwater in particular is stored better and released more slowly. And also we find other ways of possibly ponding sewage, rainscape projects and various other things that reduce the pressures on CSOs. But the money required is large, and the amount of land required is also substantial.
Claire, do you want to unmute and ask your question?
Hi. No, I actually sent you a little message, Tony, saying I thought it had largely been answered. So my question really was, I suppose, in your experience, Steve, is it a lack of political will, or is it a lack of knowledge about what to do? I know that's a quite simple question, but I just wonder what your experience is.
I think we're dealing with a very expensive, intractable problem is the first thing. I think we probably do know what the solutions are, but there are all kinds of competing interests. So, in the case of agricultural pollution, farmers very often are concerned about the cost of regulatory burden that reduces the, the cost of the produce, which is already quite marginal in some cases. Political will, I think, is becoming a very interesting area, in the extent to which pressures from citizens groups, wild swimming groups, environmental NGOs, really are now cranking up the profile of this problem, to the point that the Environment Audit Committee in the Commons is meeting this week. It's been running an inquiry into this area. We've got MPs who are calling for releases of raw sewage into rivers to be stopped. So I think if there was the political environment is certainly changing very, very substantially. And on the the programme that Tony mentioned at the top of this presentation this evening, Britain's Dirty Rivers, I was asked at the end of the programme whether I had hope that action would be taken. And my biggest source of hope, in fact, arises from the extent of interest which citizens are now taking in the quality of rivers and what it means for this incredibly important resource that we all require to live on, but also the well-being and functioning of rivers as biodiverse ecosystems. So the politics are changing.
Claire Whiteleg, I can't see you, but I know you probably wanted to say something about catchment-based approaches.
I wasn't intending to comment, but I just thought it might be a helpful resource for people. So I work for the Rivers Trust. I'm just really interested to hear.
Can you just speak up a little bit? Could you just speak up a little bit?
Is that better? It might be my microphone. Apologies. Yeah, and I wasn't intending to comment particularly, but I work for the Rivers Trust. So I just thought that given the discussions we're having on the complexity of how to manage the issues in the catchments, that might be a really helpful resource for people to have a look at what's addressed in the catchment-based approach, which is run by a number of organisations in partnership to cover issues like urban pollution, diffuse pollution, agricultural pollution, and some of the nature-based solutions and things which Steve has also mentioned. So I thought it might be a helpful website, really. Mm-hmm. Thank you, Steve, really interesting talk.
So Claire, just to also, one of the things that also came out of Britain's Dirty Rivers was how much anglicised thinking there is in this. And I, as a Lancastrian working in Wales, of course, I am an imposter, but the equivalent of the Rivers Trust in Wales is Afonydd Cymru, Welsh Rivers. Mm-hmm. So we have kind of parallel organisations, but I was a founder member of the South East Wales Rivers Trust, one of the first Rivers Trusts in Wales, and I also was a trustee of the Rivers Trust for 3 years as well. When all in
oh, that would explain. That would make sense. Yeah, that you've got some connections.
So they got 3 years of good service out of me.
Good to meet you. Yeah, I had the pleasure of meeting Arlene recently. So yeah, that's brilliant. Thank you. And just another thing to mention as well, that I'm working on a plastics pollution project at the moment, and just talking about the English-centric focus, but that project is an EU-funded project working in England and northern France with Interreg funding, and we're basically looking to apply a catchment-based approach to macroplastic and microplastic and how they move through the catchment. So I won't take up any more time than that, but the link's on the chat if anyone's interested.
Yeah. It's an interesting issue, because I'm not sure if we've absolutely, and we've published work on this, that we've absolutely correctly inventoryized all the sources and fluxes of microplastics in catchments. So, and until that, that's some of the work we're moving into, in particular around things like, tire dust. There are about 40 million tires sold in Britain every year. They each lose in their lives about 4 kilograms of plastic type material, which all goes somewhere. But you won't see that in any of the assessments of plastic sources and flux through rivers. So there are some really big unknowns in this area, actually.
That's exactly what the project is actually. It's probably similarly and in parallel to you, is looking to address. So to look at all of the sources across the catchment. So we're using a citizen-based approach to quantify macroplastics, and then the university partners, including University of Plymouth and Queen Mary, are looking at microplastics. And just to say, for the benefit of the friends of the CAM, one of the catchments that's part of the project is the CAM and the ooze. So if Tony, do feel free to pass on my email contact, because we can involve people in, basically, one of the tools we're using is to work with community groups who do litter picks, and getting them, as you say, Steve, to quantify and record all the different types of plastic that they find at different points along the catchment, to create a large database that we can be studied across all of the 8 catchments. So I just don't want to take up too much time. There is also work within the project going on tire particles as well, done by the University of Plymouth, and as exactly, yeah, absolutely right. It's a really quite a frightening source of microplastics that's going into our rivers, that one. So we
didn't pull out microplastics, but we did pull out some large plastic from Jesus Ditch, which is runs off the can. Well, we also pulled out a double mattress, a bicycle in good condition, and a very nice chair, which I shall renovate and then sell off to the highest bidder.
That's fantastic, a bit of reuse. Well, yeah, if you want to talk further, Tony, then do drop me a line, because it'd be great to perhaps capture all your data on that.
Yeah, it'd be lovely to see you sometime in Cambridge. That'd be good.
Great, thank you.
Monica, you want to ask about measurement? Are you around?
Yeah, hello.
Well, there you are.
Yeah, I was just wondering if you're aware, Steve, of any sort of easy way that amateurs can just measure pollutants, main pollutants in their local rivers. And also if you know of any emerging technologies that are being developed to help with things like that you've been talking about, like microplastics and possibly the tire dust.
So this allows me to make a bit of a point, actually, around the importance of citizen science, but also the challenges of maintaining the quality of data and the long-term nature of data. So I did have a slide, but I didn't show it. So and I will come on, Monica, to answer your question eventually, but there's going to be a bit of preamble to it, okay? But the regulatory bodies in England and in Wales have gone through really very substantial reduction in the amount of chemical and biological monitoring that they do in the river environment. So in the 80s and 90s, we had something called the General Quality Review, where large numbers of locations, 20,000 locations, were monitored every 5 years, and some intervening. That number has declined progressively. Water Framework Directive brought it down further, and there is now a new system emerging in the Environment Agency of what's called Sentinel Agile sites, which will reduce the monitoring effort even further. So there is a real challenge here in, this is affordability and cost when central government granting aid for monitoring and environmental assessment has been declining, and it could very well decline further as we pay for COVID. So one of the suggestions that very often comes up is whether citizen scientists couldn't help to fill some of the gaps that are left behind by professional monitoring. Well, yes, if it's appropriately assured in quality terms, and yes, if it allows us to continue these interdecadal data sets over very large areas that allow us to see the trends in the British river environment. And I think that's, that there's a bit of a challenge there. Now, to go to your question, is there any emerging technology and kit? Some of the most affordable, straightforward things that are now being used by citizen science groups are nutrient monitors. So there are really effective pieces of kit which you can take into the field and measure things like phosphorus and nitrogen concentration, and they work quite well to quite a high standard. Some of the other things that we've been talking about, complex chemicals, are far more difficult, and microplastics, I think, is one of those. One of the biggest issues of looking at microplastic concentrations in anything is the degree to which there is microplastic contamination everywhere. So any microplastic assessment has got to have what are called procedural blanks that tell us what background contamination there is in samples relative to real samples, and procedural blanks nearly always are contaminated by plastics. So unless things are being done to a very high level of control in laboratory circumstances, this is a really difficult thing to do. I think there is mileage and opportunity in assessment of, you know, large plastic particles, large plastic sources, but the microplastic end, I think is a challenge. You know, these are quite often very small particles down to micron sizes up to about 5 millimeter. And then even beyond that, there is a much smaller set of what we call nanoplastics that, you know, at the moment, very few people understand.
Do you want to say anything else, Monica, or shall I move on?
I can move on, yeah.
Okay, Terry.
Could I comment briefly, Tony?
Where are you? Claire. Yeah, comment away.
Thank you. Just to back up exactly what Steve has said, that the regulation and monitoring of our rivers has declined due to the funding over a number of years. And I thought participants might be interested to note. So Rivers Trust, in partnership with a number of other water companies and another number of bodies and Ofwat, have just started a programme to set up, is pretty much exactly what Steve's describing, a network where we can support communities to do catchment monitoring in the local environment. There will be a focus, as I understand it, on nutrient monitoring. I've put the link in the chat. It will be operating in the Cameo catchment and will be quite a wide scale project across 9 river catchments in the country. So it's really just trying to harness that appetite that Steve mentioned to enrol communities into the monitoring in an organised way, as Steve was mentioning, because there's a lot of groups doing bits of monitoring here and there, and it's about getting good quality data, bringing it together and using it in an effective way, and that's what the partnership is aiming to do. It's just about to start. And also just to say, yeah, exactly as Steve said about with the microplastics, that's much more of a challenge. So I'm not quite sure at this point where that's going to fit in, but I thought that might be a helpful link for people, and that there will be opportunities to take part in the CAM.
Yeah,
I've just put up there that these are the slides that I didn't show, but these are all publicly available data. This is invertebrate sampling in English rivers at the top, Welsh rivers at the bottom, the number of samples taken and the number of sites sampled on an annual basis. So left hand at the top in 1990, you know, well in excess of 15,000 samples being taken, now down to some hundreds, 7,000 sites across England and Welsh rivers, now down to about, what is that, 1,800 or so. But it demonstrates, not only does it demonstrate the reduction, but it also demonstrates this very important long-term data run that tells us how things have changed over what is now 30 years. And these data are absolute gold dust. If we don't maintain runs like this and we try and replace or recreate it, we will throw away this baseline, which brings in a whole set of different problems. And that's just equivalent data for chemical sampling, samples on the left and number of locations on the right. So,
oh, thanks.
Yeah, absolutely.
Really good. I mean, you know, I always have this thought that when we know that there's a problem, and it's a bit like you were saying about the loss of invertebrates, when we know that there's a problem, we should address the source of it. So when we know that the sewage company is illegally dumping sewage regularly in our river, to monitor it further rather than to get the water company to stop illegally dumping sewage is, you know, that for me, that's where my priority is at the moment. But Terry, I think you had a question.
Yes, I did have a question. If I could just make a quick comment before I do ask that question, which is just around those very depressing figures you show around the massive reduction in monitoring. And it's interesting that we're looking at 30 years, and 30 years is roughly the period under which water has moved into private hands. And there's no doubt about it, there's a sort of huge support for sort of corporate business inside governments, and austerity and cutting back on public services all feeds into a picture where sort of corporations are given much more leeway to do exactly what they want, to the detriment, as you show, of the water systems. My question basically was, you've talked very eloquently and given us some fantastic data about the sort of direct impact on biodiversity connected with those river systems. But I just wonder whether you could, as a biologist, put it into a wider context of what this means, the degradation of the river systems and freshwater at a faster rate than anywhere else, what impact this has on the wider, you know, the air, the earth, all the wider species, and ultimately ourselves as a species.
Mm. I mean, this is an enormous debate, okay, in its own right. So there are two big schools of thought around biodiversity conservation. One is around the protection of biodiversity for ethical reasons because organisms have intrinsic value. The other area of argument is the utilitarian argument, where we need biological diversity to keep us alive. And my own view is that we need a combination of those two things, and that comes out of a kind of you know, what I think is a potentially dangerous line, where if we want to maintain most of the critical ecosystem functions on Earth, it is possible that biological diversity could decline because most production decomposition is driven by just a percentage of the species that are present on Earth. And I think, therefore, that puts me in a space where that utilitarian ecosystem service argument about things, life support systems, is got to be an adjunct to ethical conservation and intrinsic value. So I think we've got to do both. Now, however, let me say that there is a caveat, which is that in the end, we are dependent on all kinds of processes for our well-being that can only be delivered by ecosystems and organisms. And there is what is called the insurance hypothesis, where if we lost some important species that was critical, let's say to fisheries production, another species could easily expand in abundance to fill the niche of the one that we've lost. And all the organisms that are now scarce and not contributing strongly to production or decomposition or other aspects of life support are there as insurance. It is critically important that we maintain and restore the integrity, the production, the diversity of degraded ecosystems, partly for life support in its own right, but because we cannot know in the next decades to come, our future generations, what they will need that we have potentially led to the destruction of in our lifetimes. You know, the genetic resources that could go into drugs, the potential sources of protein that could be critically important to future farming and production. There's a whole range of good reasons on which we depend to actually maintain the integrity and to restore ecosystems.
Alan, have you finished, Terry? Or... Yeah, Alan, would you like to? Where are you? Are you around, Alan, or are you trying to unmute? Yes, I can see you, but we can't hear you as yet.
Maybe that helps.
That helps a lot.
Sorry about that.
Oh,
yeah. I've got that. I've put up a question, but I've also got I've also got a thought as well. We've been involved in a lot of air pollution monitoring and measurement, and of course particulates from tires and exhausts and so on are the things we've been monitoring. And there's quite a lot of kit out there now which anyone can use who's got a computer. And I just wonder if we can draw maybe some kind of relationship between the levels of air pollution in areas which will subsequently cause a threat to rivers, because these particles will come out of the air and get washed away when it rains. And I just wonder if it would be worth doing some work on trying to build a relationship between the two types of monitoring, air monitoring and water monitoring. But that's just a off-the-wall thought. But meanwhile, we do have this problem in Cambridge that we have in central Cambridge a water treatment works which is working perfectly, is not up to capacity, doesn't discharge into the river, but the water company wants to move it so that it can make money out of its land and move it into the green belt. And meanwhile, the smaller facilities that we have, which discharge into the CAM, it's not investing in and are causing significant discharge. So how do we find a way of forcing Anglian Water to invest in the small facilities that need investment, and to halt this crazy move purely for money of its main water treatment works? Any thoughts, anybody?
That sounds like a particularly local issue to me. I'm not sure if I can help with that one.
Yeah, but you can answer the first bit if you like, Steve. That might be
well,
relationship between air and air quality and water quality.
So the example I started out with, the acid rain example, is absolutely that. So the reasons that there were two things required for the acidification of surface waters. One was base poor rocks and soils, but the other was the deposition of acidity from the atmosphere that was produced by the burning of fossil fuels. And acidification would not have existed but for the fact that those two things co-occurred in several places like Wales and Scotland and Scandinavia and the Laurentian Shield and parts of California. So it was exactly that, an atmospheric deposition problem that gave rise to what at the time was considered to be the most significant of all sources of pollution in Welsh rivers. So 24,000 kilometres of river in Wales, about 12,000 were affected by acid deposition. That's what that was. And there's a whole range of other issues around, motorways, for example. If you drive your car along a motorway, as probably many people do, because in the end pollution is caused by all of us, your gearbox is losing bits of metal, your tires are degrading and losing bits of rubber and vanadium and various other things, your clutch lining is burning, your brakes are burning. All of that material is first of all an atmospheric pollutant, but then it becomes an aquatic pollution because all the drains coming off motorways go somewhere. Now, whether you would ever be able to design a scheme to monitor both simultaneously, I think is a really substantial challenge, and it's because different pollutants travel different distances in the air. So when we had problems of acid deposition, some of our emissions were arriving from Central Europe. We were exporting our emissions to Scandinavia. So, the extent over which monitoring and source apportionment can occur in a way that takes you into a position where you can make appropriate policy is a bit of a challenge. But different pollutants you can do it with. It is possible with something. Ammonia doesn't travel very far, for example.
Right. Yeah. Just perhaps one of your students would like a research project, Steve.
But my students are always looking for funding, Alan. If there is, if you carry it out, they'll be knocking at your door. So.
Okay.
If Stuart is still here, I think Stuart Bain, are you around? because you wanted to ask a question about the runoff of, is there a way of filtering out? Now I'm asking your question for you. Are you around?
Hi, Tony.
There, he's unmuted, yeah.
Where are you?
I think it's already been answered
Oh, there you go.
It's already been answered by Monica's earlier question. So
Okay.
I think the easy answer is probably not at this stage.
Okay.
Thank you anyway.
Okay, but it's nice to see you. And Will, you had a rather different question asking about reed bed technology. If you could unmute, would be great.
Yeah. There you go. I was just thinking about the management of catchments really for rural areas. If you one thing that you can do if you build your own house out in the country or whatever is not attach it to the sewage system, but use a reed bed to clean up your own sewage, basically, to absorb all of the nutrients that are going in, to have the microbes associated with the sewage actually attacking and breaking down any waste and so on. And I was just wondering if all drains eventually lead to a watercourse. What could be done is either incentivize farmers or mandate farmers to actually create massive reed bed systems so that all water draining off of farmland goes through a big reed bed system to remove an awful lot of the problem chemicals before it actually empties into the watercourse, and whether that's a practical solution that could be brought about.
Well, it's in the class of nature-based solutions, isn't it? And that, you know, the use of wetlands, whether it be wetlands, riparian planting, sustainable drainage systems, they are all in that class of nature-based solutions, which I'm sure we will see an expansion of, and they come in various permutations and forms. I must be about 25 years ago now. I went to look at a series of projects in southern Sweden, and the various countries around the Baltic, Poland, Germany, Finland, Sweden were all concerned about nitrogen concentrations entering the Baltic, and there's a difference. Marine systems tend to be impacted more by nitrogen, freshwater systems tend to be impacted more by phosphorus, and all of these villages along the rivers draining into the Baltic essentially had developed at a local community scale pond wetland systems that were in line along the rivers to essentially denitrify, to volatilize nitrate as nitrogen, well, volatilize various nitrogen species as nitrogen gases. So, you know, the concept is there if the investment is there, and I guess agri-environment schemes are probably one of the likely sources to pay for some of these kind of things, but also appropriate, you know, reward to agriculturalists for appropriate behavior. Markets for ecosystem services is another way that you can incentivize these things.
Yeah, farmers have been incentivized since the Second World War. Farmers have been incentivized to do
the wrong things. Yeah.
Rip out hedges, put hedges back in, grow trees, cut trees down, whatever they are. But they react to whatever incentives are put there by governments, and it just seems one sensible way to do that. I mean, we talk about set aside and so on, putting aside sufficient water to do that sort of system would bring about rapid improvements, I think, in all rivers before they get to city environments, so that they're not polluted before they get there. But the other thing is that it's also this thing about flooding that we're going to get, and flooding will affect the Cam and that area an awful lot in future years. And I again, from working on the ooze system that we did, we were talking about actually breaking flood banks and having big lakes formed which act as a reservoir for water when it comes into flood, so that land only floods when the river comes up. And then it acts as a nursery as well for insects and for all of the other all of the rest of the animals in the ecosystem, so that when the river then goes down, it's actually being recolonized by all sorts of things, including fish. Now that again only takes some incentive from government to farmers to actually create big lagoons basically along the sides of rivers, and we would get an awful lot of problems solved.
So we are heading towards the end of the session very, very soon. I don't know if you have a final word, Steve, but I do want to thank you hugely for what has been a fascinating presentation. I certainly want to watch it again. It's been, and your handling of discussion has been wonderful, and I'm left feeling there's so much more for us all to talk about, but we do have to come to an end. What I'd like, while you're thinking of, if you have a final word, what I'd quite like is if everybody could unmute, and it would just be a kind of human thing to do, to give you a round of applause if we can. So unmute if you can, and
put it on mute first of all.
Yeah, maybe we'll.
Well, thank you. You're very kind. Tony, you did have Janine, who was desperately trying to get in and ask a question. So, Janine, I can make an exception, and I'll answer one last question. And then
where is Janine? I can't see it. Have I missed it?
Up in my top left-hand screen. Go ahead, Janine.
Oh, there you are, Janine. Janny.
Sorry.
Oh, my friend Janny, and I didn't realize you were waiting. Of course you should ask your question, Janny. And then we can clap you again if you like.
Absolutely. Yeah, because I just wanted to go back and re-emphasize both the point that Terry made and also the points that Alan made about the fact that many of the problems that are besetting us have happened during the 30-year period since water and rivers and the whole issue was privatized. And on a macro scale, I think we have to be fighting to reprivatize our natural resources, you know. I mean, like,
you don't mean reprivatize, you mean to renationalize.
Renationalize, excuse me. Yeah, see, I'm so confused. Renationalize, you know, and I mean, I know there's a tremendous amount of goodwill and amateur enthusiasm about doing some of these things, which should be being carried out by government, and the excuse of not having the money to do so is total nonsense. You know, they have the money to do things that destroy the planet, but they don't seem to have money to do things to save it. So I just wanted to maybe underline that point. And as much as you know, everything Steve's it's said is really fascinating, and I mean, I defer to the experts on, you know, in every area, except for the fact that we don't have the time. We don't have the time to let our things go as they're going at the moment, because nature won't have time. You know, we don't have time for nature to come and get us on the right path again. So that's all I wanted to say.
Thanks, Jenny. So I give you a final word, and we'll give you another round of applause.
No, I don't need another round of applause. But so just a bit in response to Janine, one of the things I think we forget is that we've got more than one. Well, let me say something else first of all. As I started my PhD in 1981, I actually worked in what was still a combined water sector. And one of my PhD supervisors worked for what was then called Welsh Water Science Directorate, my other supervisor was the deputy chairman of that same company, and they were combined. And I was present at the birth of the National Rivers Authority when it came into being. We have a series of different models in Britain of water companies. So Wales, we have ostensibly a not-for-profit company. Scotland is different again. And then, of course, in England, you have mostly private companies. So there is a spectrum of operation, and the argument about renationalisation is quite an English one, interesting, you know. But you know, it's an extremely interesting debate. But Tony, just to thank you and the friends for inviting me to come along and talk to you. I just think it's incredibly important that we care about river environments, that we do initiate action, and we put pressure on those in political positions to make the right kind of decisions about what we do in future. But again, thank you very much, Tony, and Susan and Monica for inviting me along.